continuing our series on algebraic equations, and this video is going to be algebraic equations 2. Obviously you can tell by the number. So in the last video, just to give you a quick recap, we solved one-step algebraic equations using either addition or subtraction. So today we're going to do the same kind of thing as far as one-step problems. Well, actually, one- and two-step problems, but we'll get into that later. We're going to do basically one-step algebraic equations that will be solved either using multiplication or division. Okay, so we did addition, subtraction. Now we're going to do multiplication and division. Okay, so so you guys all remember this thing, right? To solve equations, it's based on opposite operations. Or some people like to say inverse operations, whatever. So like I said in the last video, we did the addition, subtraction, so now we're going to be doing the multiplication and division. Alright, so again, just to recap, we're always trying to find x, trying to find the value of x. That's the whole point, that's the purpose, okay? And to do that, we need to isolate x on one side. Doesn't matter which side, but it has to be alone, isolated, on one side of the equal sign. So it can look like x is equal to something, or something is equal to x. Doesn't matter, but that's the point. We try to get x by itself. Now I say x, and I'm going to use x in all of these examples, but remember that the x is just a variable. It can be any letter. It can be a B, an S, a T, any letter that's in the alphabet, okay? I just think that it's more common to see x. Anyway, okay, so I'm going to use x. So let's get started. So keep in mind that the one-step algebra problem or algebraic equation is going to be, you can visualize it like the last step of a multi-step problem, okay? So in the later series, after 2 obviously, 3, 4, 5, I'm not sure which one, but we're going to start doing multi-step problems, and they're going to get increasingly more complex, or at least more work to do, more steps to do to solve the problem, okay? So again, imagine these ones that we're doing in these first 2 videos as the last step of a bigger problem. That's all there is to it, okay? Alright, so we put the first example up there. Now these first ones that we're going to do, I would consider them to be like the most common, like at least 80% of the time, probably more, I don't know. And yes, I am making up the statistic, the percentage, I'm just making it up. But these ones tend to be the most common, at least from what I've seen. Okay, this is a one-step algebraic equation. We know it's an equation because it has an equal sign and information on either side of that equal sign. So my first thing to do is I like to mark where my equal sign is. This is the habit I picked up to maintain organization as I solve these kinds of problems. Especially the more complex they get, it's easy to lose where that equal sign is, just so you know. I've seen students do that. They're doing a big old problem and that equal sign starts to dance around as they start doing all the steps. And as a result of that, they tend to make mistakes and get the problem wrong, okay? So we don't want to do that. We want to not get the problem wrong. All right, so remember, we're trying to find x. We're trying to get x all by itself on one side of the equal sign. Well, where is the x? First of all, the x is on the left side of the equal sign. Okay, so is it alone? No, it's not alone. Who or which number is with the x on the left side? Well, the 2 is. Now, we don't want to know what 2x is. We want to know what x is. And remember that in algebra, when they just put the number right up next to the letter or the variable like this, a 2 stuck right together with the x, it means that the 2 and the x are multiplied, okay? So we know that this says 2 times x is equal to 10, or you could even say 2 times some number is equal to 10. And I'm pretty sure most of you can already see that it's 5. 2 times 5 is equal to 10. But we're not trying to guess, okay? We're trying to practice the steps, the methods of separating the 2 from the x and getting x isolated. As you know, these are going to get more complicated, so we need to know, we have to have a procedure in place. And I know you can probably guess it. It's not the point. We're trying to work out the methodology, the procedure. Okay, so like I said, the 2 and the x are multiplied together. So to undo the multiplication, because that's what opposite operation means, and I could even say inverse operation, I need to do the inverse of the multiplication, or the opposite of the multiplication, and that's going to be division. Okay, so I need to divide. And remember that in algebra, at least at this point in math, we're going to be using fractions to do that division. So I want to divide the number and the sign that I'm trying to get rid of. I'm trying to get rid of the 2. It just so happens that 2 is positive, and the way I know that is because they don't put a sign here. If there's no sign, you can just imagine it as a positive. Okay? And it's important that I say that. Some students like to do this. They like to divide the whole thing out. It's like, no, you don't want to do that. You want to leave the x there. We're trying to leave the x alone. So don't put 2x on the bottom, okay? Just put the number, not the variable, just the number that you're trying to eliminate. And its sign. So if it's positive here, you want to put the same, you want to think about it at least as the same sign, okay? Very important. Okay, so 2 divided by 2, or positive 2 divided by positive 2. This is going to be a positive 1. And like I said, we didn't do anything with the x. We can just bring that x down. And I think I've already mentioned this at least at some point. Probably distributive property or something like that in the video of distributive property. That when it's just an x by itself, they never put the 1. They never put the 1, okay? But we know it's a 1 because we divided 2 divided by 2, and that's 1. And it's a positive 1 because it's positive divided by positive. So yes, if you're thinking, well, I got to remember all about the signs and division and fractions and all that stuff to do this, yeah, you do. Okay, so, but like I said, they're never going to put the 1, so I'm not going to put the 1 either. I don't want to get, I want to get you started on the right foot as far as being able to recognize what we're looking at. But what happened is that we did the division, and you can imagine that, well, okay, hold on. So why did I erase the 1? Because it said 1 times x. 1 times x is x. The same way that 1 times 2 is 2, 1 times 3 is 3, 1 times 7 is 7, and 1 times pizza is pizza. 1 times x is x, okay? So I don't need the 1 there. That still says x, okay? That's why I'm getting rid of it, because that multiplication isn't going to change the value of this x, okay? It's going to still be x. 1 times x is x, 1 times 5 is 5, okay? So anyway, that's why I erased it. Now, what we did to this side was divide by 2. It eliminates that 2 in front of the x, and it makes it into a 1x, or just x. So, but remember, what you do to one side of an equal sign, what you do to one side of an equation, you have to do to the other side, because that equal sign says, to begin with, we gave you this problem, and both sides were equal. Both sides are equivalent. And so, if you change something to one side, you've got to do the same change to the other side, because you need to maintain that equal sign. Okay? So we're going to do the division on the other side. And it's a positive. You might want to start getting into the habit of making sure you know what sign the number is. Okay? It's just a good habit, because when they get more complex and you're dealing with positive and negative numbers all over the place, it's a good habit to write them down. Okay, so we already did this. 10 divided by 2 is 5. And they're both positive, so you can, if you want, you can put a positive 5. Okay? All right, so x is equal to 5. We knew that already from the beginning, because it said 2 times some number, and we know they're multiplied because they're together. 2 times some number is equal to 10. Well, that number has to be 5. All right? So the one step that we did was divide 2 to both sides. And that was it, and that gave us x. And like I said, this is a very common kind of problem. This is a very common last step in all of your algebra problems. So it's good to get familiar with this one. Let's do a couple more of this kind of problem. All right. I'll try not to talk so much. And we'll just get going with it. All right. Same kind of thing. Something, or a number times x is equal to 36. Well, I need x by itself. X is not by itself. I know that x is being multiplied to the 4 because they're together. I know the inverse operation of multiplication is division, so I know I need to divide by the number and the sign. You can say it's a positive. Number and the sign that I'm trying to eliminate. Okay, so I'll put the positive there. Why not, right? Okay. 4 divided by 4 is 1. 1 times x is just x, so I'm not going to put the 1. Okay, I already explained why. But what I do to one side, I have to do to the other. Okay, I need to divide by that same positive 4, like I did over here. Now 36, or I could say positive 36 divided by positive 4 is going to be positive 9. Okay? All right, that's that. X is equal to 9. So 4 times some number, we know that number is 9, at least now we do. 4 times 9 is 36. So this is 36 is equal to 36. They were equal. Okay, moving on. So this is pretty easy, right? I mean, this shouldn't be too complicated, at least not yet. I think where algebra gets more complicated is when the problems get big and there's a lot of stuff to maintain organized, or where we got to be very careful with our signs and that kind of thing. But the basic concept of algebra is this. It's just an opposite operation. Anybody can do it, with a little practice, of course. So let's put up another one here. Okay, now this one, we change it up just a little bit. It's still a number times x, but that number is negative, okay? Number times x is equal to 20. So negative 5x, or negative 5 times x, and I know they're multiplied, just to repeat, because they're right next to each other. There's not like an addition separating them or something like that. So they're right next to each other. That means that they're multiplied. So minus 5 times x is equal to 20. Minus 5 times some number is equal to 20. I think some of you can already figure out what that number is, but let's go ahead and do the operations. Now I know that I want x by itself. So to get x by itself, I have to do the opposite operation with the number that's together with x. So I know that x is not by itself, it's hooked together with minus 5, and I need to do the opposite of that. So this is where students might get confused. They see a negative here and they say, well, the opposite of negative is positive, and they'll do that. It's not right, because originally the minus 5 isn't subtracted to the x or added to the x. It's actually multiplied to the x, and that multiplication supersedes, or that multiplication is more important than this like negative or minus sign. Okay, so it's not a minus in the conventional sense. I guess maybe what I could compare that to would be something like this. Right here, now this is a different kind of term. These are obviously different, but the thinking behind it, to separate these two numbers, the x and the minus 5, here I would add, okay? That's supposed to be a 5. Doesn't look like one, huh? Okay. Well, it's not much better, but it's a 5. Okay, so to eliminate it, this is where I would add or do the opposite of the subtraction, and that would give me 0, leaving x all by itself, just bringing the x down. However, this isn't what it says here. We've got to understand that that multiplication is more important than a possible subtraction, okay? All right. So let's get on with it. So I know that I need to divide. So I'll use my fraction bar. I want to divide by the same number and the same sign that I'm trying to eliminate. I'm trying to eliminate a minus 5. So I'm trying to eliminate a negative, and I'm trying to eliminate a 5. Okay? I'm going to leave the x there. Remember, don't put the x here. You don't want to get rid of the x. Ooh, sorry. That was loud. Okay, so negative 5 divided by negative 5 is positive 1. And that's the same thing that we've been doing all the time. We've been getting a positive 1, x, right? We just bring down the x, but again, 1x is x, so we don't really need to put the 1 there. Just write that a little bit bigger here. All right, so, but what we did to this side, we have to do to the other side to maintain equilibrium. So, we divided by negative 5, and that's what I'm going to do over here, divide by negative 5. Now, the 20 doesn't have a sign to its left or in front of it, like right here. So that means that it's positive. 20 divided by 5 is 4. Positive divided by a negative is a negative. Okay, so x is equal to negative 4. This is why algebra gets confusing for a lot of people, because the signs really get in the way, I think, for a lot of beginner students when you're starting to learn this for the first time. So keep practicing, okay? Don't get discouraged. It takes practice. All right, so what we were saying is x is minus 4, so minus 5 times, or let me say that again. Negative 5 times negative 4 is positive 20. Remember that, right? Negative times a negative is a positive. All right. So again, this is a common kind of problem, very common. I think at least 80% of the equations that you'll see for your high school equivalency diploma are going to be very much like that. At least the last step of those kinds of problems. So we're going to move on to the next kind of one-step problem. We did the multiplication, we did the division where we divide both sides by something to get the answer. Now we're going to do the division. We're going to divide both sides by something. Make sense? Am I saying that right? No, I'm sorry. We divided already. Getting my words mixed up. We're going to multiply to both sides of the equal sign to get to the answer in one step. All right, so here's the first example. Uh-oh, right? Everybody sees a fraction and they panic. At least many of my students do the first time they see it. They're like, oh, what? You mean I got to go back to fractions? I thought I did all the fraction work and I'm done with it. Well, no. You can't get away from fractions. There's fractions in every aspect of math. So get used to it. Better make them your friend because you're really not going to have a good time if you don't make good friends with them. Okay, make friends with the x's. With the fractions. So again, first step is the line. All right, so 1/2 x is equal to 5. I need to get rid of this fraction. I need to get rid of this 1/2. How do I do that? I know that there's a half multiplied to the x. Yeah, it's kind of a weird problem. It's hard to explain. If you go back to the video when we talked about how to multiply and divide fractions, you need to know those skills, okay, to be able to solve this problem. So I just want to put that out there. Go back and check that out. So what I need to do is eliminate the fraction. I'm not really going to eliminate this multiplication so far, this half times an x. I'm not going to do that so much. I'm really just going to focus on getting rid of this fraction. And to do that, and don't worry, when we get into the bigger or the subsequent videos that follow, I'll be doing more of these with fractions that are a little bit different, okay? In other words, I'll maintain the multiplication, I'm just going to get rid of the fraction part of it. In this one, getting rid of the fraction actually gets rid of the whole thing. So you'll see what I mean in the later videos. I don't want to get too caught up in that right now. Okay, so I know that this half is multiplied to the x, and you might think, well, why don't you just divide both sides by half? And you'll get the answer. You can. That's one way of doing it. But I find students find that more confusing. Let's just see how this goes for you. I'm going to focus on this. I'm going to focus on the denominator, on the 2. I can get rid of that 2 pretty easily if I multiply by 2. So let me do it down here. All right, there's a half. We're going to leave the x here for now. You can imagine I'll be putting the x right back over here in just a second. But if I want to get rid of a denominator, like 2 or 5 or 8 or whatever, I need to multiply by its inverse. Remember what inverse is. It means it's opposite. You can flip it over. Okay, so that's what I want to do. It's like 1 is divided by 2, so to get rid of that, I would multiply by 2. And remember that in fractions, if you want to multiply fractions, you need to have everything in fraction form. So I can't just leave 2 like that. I got to put 2 over 1 to make it an improper fraction. These cancel out. You can check out the video on cancellation. I think it's in the same multiplication of fractions video. And that would mean that this is 1, that's 1. What we're doing is we're dividing 2 by itself and 2 by itself. 2 divided by 2 is 1, 2 divided by 2 is 1. Anyway, so you multiply across, you get 1. 1 times 1 is 1. 1 times 1 is 1. 1 over 1 is equal to 1. And if I bring that x down here, it's 1x. And we already know that in 1x, they never put the 1. So, all of that was just multiplying by 2. All right? And that's what we need to do. So I'll do it again. Check it out, check it out, check it out. So again, I'm going to focus on this denominator right here. But I know I can get rid of this 2 is what I'm saying. I know I can easily get rid of that 2 by multiplying this whole thing by 2. So that's what I'm going to do. I'm going to go ahead and put parentheses just to hopefully make it easier. Remember, if I'm multiplying by 2 and I have a fraction, I need to put everything in fraction form. That's why I put the 2 over 1. So these are what canceled out. 1, these numbers turn into a 1. Right, the 2's turn into 1s. So 1 times 1 is 1, 1 times 1 is 1. 1 over 1 is 1, 1 divided by 1 is 1. And 1x is x. So again, look, I can go through this whole process of teaching you how to multiply fractions, but really, just, you don't even have to know that much, really. I mean, you don't have to do all that work. I could even go back and say, well, okay, I know that if I want to get rid of this 2, I've got to multiply by 2. If I multiply by 2, I'll get x by itself. If this was 1/8, well, I know I can get rid of that 8, or that 8, that denominator, if I multiply by 8. If I multiply by 8 this side, if I multiply this side by 8, I'll get x. If I have a 10 in the denominator, no, I want to get rid of that 10 because it's like a 1/10 x, for example. I want to just get rid of that 10. All I have to do is multiply this side by 10, and I'll get x. So it's like, you can do all the work if you want to, but really, this is what's important. You got to know that if I just do the inverse operation, I'll get x isolated. Okay? And I still need to do that to the other side. So we did a multiplication with times 2. We times this side by 2. We're going to multiply that side by 2. Okay? And that gives me 10. Okay, so we're saying that half of x is equal to 5. Half of 10, because x is 10, is 5. That's what we're saying. Or 1/2 times 10 is 5. Okay? All right. I'm going to do a couple more of these, I know. It's kind of hard to explain. I mean, and there are so many different variations of these kinds of fraction problems. So I'll try to do my best at touching on all of them throughout the series. Again, keep an eye on that number. Okay, so let's do another one. Is equal to 5. Again, 5. All right, what's the first step? Easy, right? We just put the line. Boom. Again, all I'm going to focus on is I want to get rid of this denominator. I can do that. I can always get rid of the denominator by multiplying by that number. So I'm just going to multiply all of this by 4. If I did all the work right, I should get x. How about we just say I did the work okay? I did the work right. It's done. Right? I get x by itself. What we're doing, though, is we're doing this. Right? We're multiplying a 4 over 1, or 4, times 1/4. These will cancel out, leaving 1x. 1 times 1 is 1, 1 times 1 is 1. You get 1 divided by 1, and that's 1. And you'll get 1x, and we already know that it's just going to be x. Okay? So again, if you just know what the opposite is, you don't have to do all that work. You can just write down x and do that operation over there, which is multiply that side by what? By 4. And that's it. Okay, so 5 times 4 is 20. It's not too complicated, but people get hung up on it. They see a fraction and they panic. Don't panic. You can do this. All right. Let's do another one. One more of these kind, and then we'll get on to the third kind. And then that should be it. Let's see here. Okay. Oh no, we already did that one. I'm sorry. Sorry. I should have crossed out one of the ones I was doing. Okay, I'm sorry. I meant to do this one. X is equal to 20. All right. First step is the line. So I have a 1/5 x is equal to 20. I want to get rid of this fraction. I can get rid of this denominator very easily just by multiplying by its inverse, or multiplying by 5. I'm going to multiply this by 5. There, I did it. Did you see it? It was pretty fast, right? I'm that good. Just kidding. But we know, if I know the inverse, I can just multiply by it and I get the 5. I get the x all by itself. And I guess one thing to point out is all these fractions had one thing in common. The numerator was always a 1. And that's actually kind of important. I guess I should probably do one where that's a little bit different, and then it'll be like a 2-step problem, okay? I'll do it on the next one, on the next video. All right, so we're going to multiply this side by 5, and that just has to be a 5 over 1 so that we get a fraction, and we cross-cancel, blah, 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 you get 1, blah, 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 1 over 1 is blah, 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 1x, and you get x. All right, so we're going to multiply this side by 5. 20 times 5 is 100. All right? So a fifth of 100 is 20. That's what we're saying. Or a fifth times 100 is 20. Okay? All right. So those are a little more tricky. Not the most common. I think the first ones that we did were more common. Now we're going to get into one that's even a little bit stranger. All right. And this is where I think we need to do 2 steps for these ones, okay? Or we will definitely be using 2 steps. So I have 10 over x is equal to 2. First step is to draw the line where my equal sign is. But now look, I said in the last one I can get rid of the denominator if I multiply by the denominator. Well, I don't know what the denominator is. All I know is that it's an x. That's okay. That's enough to do the operation. I don't need to know what number it is, as long as I have something to take that place of that number, like a variable, like x. So, remember, if I do the operation right, I should be left with 10, correct? So I'm going to watch this. Check it out. I'm going to multiply this whole thing by the denominator. And that's what we did in the last one, right? We just picked the bottom number and multiplied both sides by that bottom number. This is going to be x over 1. Okay? Excuse me. So the x's will cancel out. I don't know what number x is, but they're gone. They cancel out and they equal 1 now. So 1 times 10 is 10. 1 times 1 is 1. 10 over 1 is... 10 divided by 1 is 10. Okay? But what I do to one side, I multiply by x. I got to do the other side. Multiply by x. That's easy enough. 2x. Boom. Done. Well, almost done. This is where the second step comes in. This was the first step. This will be the second step. Now this one looks like those first ones that we did. 2 times the number is equal to 10. Well, 2 times what is 10? That's 2 times 5. That's actually very much like the first one we did, isn't it? Yeah, it is. It's the very first one. It's just that they're flip-flopped on either side. So this says that they're multiplied, so I got to do the inverse of multiplication, and that's division. All right, so 2 divided by 2 is 1x, or 1x is going to be x. You can see that. And 10 divided by 2 is 5. Okay. And that's what we were saying originally, right? So the original problem was 10 over x is equal to 2. 10 divided by 5, because we're saying that x is 5 now. X is equal to 5. So 10 divided by 5 is 2. That's what we were saying originally. But we need to have, like again, like I say, we have to have the procedure to be able to do it, right? Because they're not always going to be straightforward, where you can just guess them like that. All right, here's another one. You know what, let's flip-flop this one over. Let's move it over to the other side. 9 over, okay. All right, 3 is equal to 9 over x. First step, my line. Second step is to try to eliminate that fraction. And to eliminate a fraction, all I can do is multiply by the denominator. Whatever that denominator is, if I multiply that side by it, it'll get rid of that denominator. Okay, but I got to make sure I do the same thing to this side. All right, so let me move this 3 over because I can already see I'm going to get kind of crowded there. All right. So I want to multiply by the denominator, x in this case. I'm going to multiply this side by x, but I need to make x a fraction to do that because I have a fraction here. And to do that, I just put it over 1. Number over 1 is that number. X over 1 is x. So the x's will cancel out through cross-cancellation, leaving 1 on both sides, or 1 in place of the x. So 9 times 1 is 9. 1 times 1 is 1. You basically get that, 9 over 1. 9 divided by 1 is 9. Okay, let me make that a little bit bigger. All right. But what I did to that side, I got to do to this side. So I multiplied that side by x. I'm going to multiply this side by x. It's very easy to express. Just got to write the x right next to the number, and that shows that it's multiplied. I'm going to just go ahead and bring it down. That's a nice suggestion, I think. It's a nice start. After you do one operation, is to start fresh with the rewritten version of that equation. Okay. Organization is key. Now, this is like that first kind of problem that we did at the beginning of the video. 3 times a number is equal to 9. You can already probably guess it, but I'm going to do the operation. So this says that they're multiplied. I don't want x hooked together with 3, I want x by itself, or isolated. So I'm going to do the inverse operation of the multiplication, okay, because that's why they're multiplied, that's why they're together, they're tied together by the operation of multiplication. So I'm going to undo that by dividing, do the inverse operation, the opposite operation, to both sides with the equal sign. 3 divided by 3 is 1, 1x is x, and 9 divided by 3 is 3. Okay, so 3 times a number, 3 times 3 is equal to 9. Or you could have said it was like this originally, right? It was something like that. 3 is equal to 9 divided by a number. 9 divided by 3 is 3. All right, so that's my little lesson for you today. I'm going to do 3 more, but I'm going to have you try them first, okay? And those problems are these ones. So the first one is 18x is equal to 36. Got to find what x is. This says 1/6 x is equal to 36. And 20 divided by x, or 20 over x, is equal to 4. All right, so I would say go ahead and pause the video like I always do. I always ask you guys to do that. Pause the video, do your best. See if you can get the answer. These are one-step problems. Well, with the exception of this one, this is going to be a 2-step problem, but that's okay. All right, don't be afraid of fractions. Go ahead and pause the video. Okay, so let me rewrite them. I'll do them one at a time. So the first one is 18x is equal to 36. All right, first step, line. I like the line. I know not everybody uses that, but I like it. Okay, so this says 18 times a number, 18 times x, and I know they're multiplied because they're right next to each other. And so is equal to 36. Now I need x isolated. I can't have it together with 18. So how do I undo that? Well, I got to divide because it says multiplication. Opposite or inverse operation of that is division. So I will divide both sides by 18. 18 over 18 is 1x, but the 1, I meant to do that. All right. So back to what I was saying, 1 times x is x. They never put the 1 there. All right, so my equal sign goes on the line. And then I do the operation on the other side. Divide both sides by 18. I did this side, now let's do the right side. 36 divided by 18 is 2. So you should have got x is equal to 2. All right, let's do the next one. Got 2 more to go and we're done. The next one was 1/6 x is equal to 36. Now remember, when we have a fraction, well, first step, don't forget my first step, but when we have a fraction, I can get rid of the denominator. Getting rid of the denominator would eliminate that whole fraction. And to do that, I multiply by that denominator, okay? So I'm going to take that whole term, put it in parentheses, and multiply it by 6, or 6 over 1. And the 6's will cancel out, leaving a 1 here and a 1 there. 1 times 1 is 1. 1 times 1 is 1, the fraction bar. Bring down the x. 1 divided by 1 is 1x, and 1x is x. Maybe I should have done it like that the first time, huh? Well, I hope you understand that by now. I'm just going to leave all that there, put my equal sign here. So what did I do over here? I multiplied by that denominator by 6. So that's what I got to do over here. I got to multiply this side by 6. Oh man, I didn't anticipate this. What's 36 times 6? I got to do it by hand, people. Sorry. I didn't prep that one. But that's okay. 18, 19, 20, 21. I get 216. So I guess you guys can check it and see if I'm right or if I'm wrong. But we're basically saying that a sixth of 216 is going to be equal to 36. And that's that. Okay. Now, you probably saw me counting on my fingers. That's fine. Count on your toes if you want. Okay. Don't feel bad. I have students that get very self-conscious because they're counting on their fingers, or they feel like that they're not good at math because they have to write everything out. It's okay. I had to do it too. I did it right here. Did I do it right? Not exactly sure. I'm pretty sure I did pretty good. Yeah, 18, 19. Yeah, okay. I think it's right. But don't be intimidated. If you do math your way, and you get the answer right, that's what's important. And it's better if you can improve it to be a little bit quicker at it, but you know, that's the whole idea. So the last one we had was 20 over x is equal to 4. All right, so again, there's a fraction, well, hang on, first step. If there's a fraction, I can get rid of the denominator by multiplying by that denominator. So to get rid of this fraction, I should multiply by this number, x. It's okay if you don't know what it is, but you have something to be like a placeholder. You know, you can say, well, I don't know what it is, but I know it's x. I can use x in place of it. That's the beauty of variables, right? Okay, so x over x, they'll cancel out, leaving a 1 and a 1. 1 times 20 is 20 over 1 times 1 is 1. 20 over 1 is 20. Okay? Now I have 20 is equal to something over there. What's it going to be equal to? Well, I multiplied this side by x. That's what I have to do over there. So I'm going to multiply this side by x. Pretty easy to express, right? I'll go ahead and bring it down. Now this is very much like that first one. Right? It's very much like this one. 18 times a number is equal to 36. Well, I have 4 times a number is equal to 20. It's a very similar problem. So it shouldn't be too difficult at this point. So I know that to isolate x on this side, on the right-hand side of the equal sign, I need to divide by 4, because right now it's multiplied with 4. So I need to do the inverse operation, and that's division. Can you see that x? Yes. And what I did over here, I got to do over here. So this is the one that was kind of a two-step problem, right? So I divide that by 4, I divide this side by 4. 20 divided by 4 is 5. Okay, so this should be the last answer. All right, so again, these are basically one-step problems, except for the exception of that one where there's 2 steps. And we solved these ones by either multiplying or dividing, and that was just about it. The next videos should be a little bit bigger, probably a little bit more complex, more than 1 step at least. And we'll try to build up on that whole concept. Okay, we'll try to get it a little bit more complex, a little bit more complex, a little bit more complex. But the idea, the principle, the fundamentals are what we covered in these first 2 videos. We're talking about inverse operations, okay? All right, so good luck, keep working, and we'll keep plugging away.